The energy of an electron of a hydrogen atom in an excited state is minus 3.4 electron volt. Find the angular momentum of the electron given that the energy of the electron in the nth orbit is minus 13.6 upon n square electron volt, h equal to 6.62 into 10 power minus 34 joule second. Let's see the solution. Here minus 13.6 upon n square equal to minus 3.4, therefore n equal to 2. By Bohr's postulate, the angular momentum of the electron is nh upon 2 pi equal to 2 into 6.62 into 10 power minus 34 divided by 2 into 3.14 equal to 2.108 into 10 power minus 34 joule second. Let's see another illustration. An electron in the ground state of hydrogen atom is revolving in anti-clockwise direction in a circular orbit of radius r. First, obtain an expression for the orbital magnetic dipole moment of the electron. Second, the atom is placed in a uniform magnetic induction B such that the plane normal to the electron orbit makes an angle of 30 degree with the magnetic induction. Find the torque experienced by the orbiting electron. Let's see the solution. First, by Bohr's postulate, the angular momentum of the electron in the ground energy state n equal to 1 is given by nvr equal to h upon 2 pi, v equal to h upon 2 pi mr. The period of revolution of the electron is t equal to 2 pi r upon v. The current equivalent of the revolving electron is I equal to E upon T equal to EV upon 2 pi r. If A equal to pi r square be the area of the electron's orbit, then the orbital dipole magnetic moment is M equal to IA equal to EV upon 2 pi r into pi r square n cap equal to EVR upon 2 n cap, where n cap is a unit vector perpendicular to the plane of the orbit. Substituting the value of V from equation 1, we get M equal to EH upon 4 pi m n cap. Second, the torque on the equivalent current loop placed in magnetic field B is given by torque equal to M cross B. The magnitude of the torque is tau equal to mb sin theta, where theta is the angle between the vector m or n cap and b vector. Here theta equal to 30 degree, therefore torque equal to mb sin 30 degree equal to eh upon 4 pi m into b into half equal to ehb upon 8 pi m. Let's see another illustration. Suppose that the potential energy between an electron and a proton at a distance r is given by minus k square upon 3r cube. Use Bohr theory to obtain energy levels of such a hypothetical hydrogen atom. Let's see the solution. F equal to minus du upon dr equal to minus k square upon 3 multiplied by minus 3 r power minus 4 equal to k square upon r4. Now mv square upon r equal to k square upon r4 and mvr equal to nh upon 2 pi. From equation 1 and 2 we get r equal to 4 pi square m k square upon n square h square and v equal to nh upon 2 pi mr equal to nh upon 2 pi m n square h square upon 4 pi square m k square equal to NQHQ upon 8 pi cube m square k square. Total energy E equal to half mv square minus k square upon 3r cube equal to m by 2 NQHQ upon 8 pi cube m square k square minus k square upon 3 n square h square upon 4 pi square m k square whole cube equal to 1 upon 6 nh upon 2 pi power 6 into 1 upon k square whole square m cube. So energy is proportional to n power 6. Let's see an illustration. Select the correct alternative.